All right, we're doing problems 1 through 5 on review day 15. The first one here gives us 3 integrals for a function f. Now, the first one tells us from 0 to 17, that area is equal to 8, and from 17 to 20, that area is equal to negative 3. So from these two pieces of information, you can figure out that from 0 to 20, the total area was 5. Okay? So then they break it differently. They go from 13 to 20, and they say that area is 7, so what would have been the other part? Well, if the total is 5 and this piece is 7, then this piece would have had to have been negative 2. So you had to go to the total from this and then break it into the pieces there. Hopefully you saw that. The next one gives us a piecewise function here and says let f be the function defined above, where k is a positive constant. For what value k is f continuous? Now, I think that they meant continuous at x equals 3 because their answer to this one doesn't actually work if, well, I'm being maybe a little too picky, but let's just assume they mean at x equals 3. So we should know that in order for these to be continuous, they have to equal the same thing. So what they were wanting you to do is to take k cubed plus 3, put 3 in for x, and set that equal to 16 over k squared minus 3. All right, and then we can actually just go right on our calculator, put this in for y1, put this in for y2, and see where they intersect, and they intersect at a. Now, the reason I have a little issue with this is if you put that back in for the second equation, 2.081 squared is a little more than 4, so I believe you're going to have a discontinuity later on in this interval. When you hit that value, you'll have a vertical asymptote there, and so it won't be a continuous function for the whole part. That's why I think they meant at x equals 3. So if you got thrown off by that like I did, maybe you answered D. I'm still a little sore over getting that one wrong. So, but this is the answer they gave for that one. 84 here gives us table. If a continuous function based on this, which of the following must be true? F has at most 1, 0. Well, it definitely has 1, 0 from between here and here, but to say that that's the most it can have, that's saying too much. F has a relative maximum of x equal 2. We have no idea what's happening after this. To say that that's the relative max is saying, again, way more than we know. There exists a value c between negative 5 and 2 where the function has to equal 4. Well, from negative 5 to 2, we went from negative 9 to 5, so we'd have to pass 4 because we are a continuous function. So yeah, for sure this has to be true. Now this one makes you feel like it should be true because it's mean value theorem idea. The problem is that it's only continuous. It did not say it was differentiable. So that's why we can't say quite that much. All right, so C is the only one for sure that we can say. This one here says that f is the antiderivative of g. So f is the antiderivative of this. That means this is the derivative of f, right? So this is f prime. And so then it says, well, where are the local maximums of this? So what you need to do is graph this function in your calculator, and we're looking for a local maximum. That's where our derivative goes from positive to negative. All right, and I believe if you do this on your calculator, you should have gotten 3.140 as that local maximum. All right, so again, understanding what they're saying here by antiderivative, I always have to just kind of read it that f is the antiderivative of this. This is the derivative of f. That helps me kind of understand it. All right, and then we get this last one here, and we're given a graph of f, and we're asked to find out which of these graphs here would be the graph of its derivative. So initially I see that f is increasing from 0 to 2. So the derivative graph has to be positive between 0 and 2. So this is positive between 0 and 2. This is positive. This is positive. This is negative. So we can throw that one off. Okay. Then it has a sharp turn. So it's undefined here. And then it's negative from 2 to 3. So we have to have a negative derivative from 2 to 3. So this is still positive between 2 and 3. Throw that one out. this one's negative, and this one's negative. All right. Then from 3 to 5, we're increasing again, so we should have a positive derivative from 3 to 5, positive here, negative between 3 and 4. So A is our choice on that one.